MRO will give us the vision to see Mars for what it will look like for us, to find the safe places, to see the chemistry of the places that we should go visit. We don't want to walk into a toxic waste dump on Mars, but we do want to go to places that are interesting enough for human occupation, human exploration, human learning. So MRO is going to be our new eye in the sky on Mars.
Ruslan Kutsmi is a planetary cartographer who worked with NASA to select landing sites for the Spirit and Opportunity rover missions.
We cannot just land wherever we like. We have to be specific when choosing a landing site for humans. They will be working on the surface for a while, and in the future, the area might be used to build a base.
As well as landing near their supplies, landing in a location where there used to be water is the top priority for a manned mission. If there's any life on Mars, chances are that's where it will be. NASA is now receiving images from the Mars Reconnaissance Orbiter showing stronger evidence of recent water flow near Mars' equator. With this new information, they may soon be able to pinpoint the perfect landing spot for humans. So once we know where to go, the next challenge is getting the lander down onto the surface, gently. NASA's Jet Propulsion Laboratory in Pasadena, California. Chief Engineer Rob Manning has successfully landed a robotic mission on the Red Planet. Not once, but 3 times. For the Spirit and Opportunity rovers, NASA came up with a simple solution borrowed from the family car, the airbag.
You might think the airbag system is very different than the rocket landing, but they're really very, very similar. Now we're thinking about, well, how do you expand these ideas to these large systems?
An airbag would hit the ground at 40 Gs. That's about 20 times what you'd feel on the wildest amusement park ride.
How do we want to land people? We don't want to land them in airbags at 40 Gs. They'll pass out. People pass out at rides at Disney World at 2 Gs.
With airbags not an option, the only choice left is to ease the lander down using rocket propulsion. But where there's rocket fire, there's potential for trouble.
The way we envision landing men on Mars is to use the rocket engines to land us softly on the surface. It's a lot like the Harrier jump jets. They're actually quite tough to land vertically, and it takes pilots a long time to learn how to do that. So you imagine doing that in a gravity field that you would never have been able to practice in. You know, if you damage the vehicle, you're not going to be able to use it to come home. Unlike the Harrier, if you have a rough landing, the mechanics come out, they fix it up, and you're ready to take off later. We don't have that luxury when we go to Mars.
And chances are good that the landing is going to be rough. The Martian terrain is unforgiving, full of craters, rocky mountains, and boulders, reminiscent of the terrain that NASA encountered on the Moon.
How do you read? 50 down at 2.5. 19 forward. Altitude, velocity light. 3.5 down. 220 feet. 13 forward.
As we were getting very close to the moon's surface, it became very apparent to the astronauts on board that where the automated landing sequence was taking them was not a safe landing site. It was full of boulders which were potentially bigger than the lunar module itself.
Roger, we're observing the dimple crater now.
Our autopilot was taking us into a very large crater, about the size of a big football stadium, with steep slopes on the crater covered with very large rocks about the size of automobiles. That was not the kind of place I wanted to try to make the first landing.
Down nicely, 200 feet. 4.5 down. 5.5 down.
Neil Armstrong had no choice but to override the onboard computer and switch to manual control.
9 forward. Eagle, Houston, you're a go for landing, over.
But of course, he didn't have a very large margin of fuel here. We were getting very close to the surface. The aim of the exercise at this point was to get on the ground.
Forward. Forward. 40 feet down, 2.5. Picking up some dust.
For the next 30 seconds, the mission and the lives of the astronauts hung in the balance.
Contact light. Okay, engine stop. AJ at a descent. We copy you down, Eagle. Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Magnificent sight out here. Magnificent desolation.
It's an interesting place to be. I recommend it.
God bless you. Good night from Apollo 11.
It was a close call, one that NASA doesn't want to repeat on Mars. So Bob Richards of Optech Industries in Toronto, Canada, is testing a new generation guidance system that will help the Mars lander spot dangerous obstacles within seconds.
One of our problems is there's no GPS on Mars or any other planet. We don't have the information infrastructures on other planets that we have on Earth. So when we get to Mars, we don't have any reference frame. It would be like jumping out of an airplane with a blindfold.
So engineers are counting on something called LiDAR. It's like radar, except instead of using radio waves, it measures distance using beams of light.
The computer screen shows safe landing sites as green, that's very safe territory, and very dangerous areas as red. So to stay away from the red, that's unsafe.
Landing on Mars is like throwing a dart at a moving target. Figuring out where it will hit is what engineers like Canadian Jean de La Fontaine call the uncertainty ellipse.
The uncertainty ellipse is the area where we know we will land within it, but we don't know exactly where within that area. Typically on Mars right now, on current technologies, it's about 500 kilometer by 100 kilometer wide.
That's like landing in an area the size of Costa Rica, but not knowing exactly where.
If we want to land close to another vehicle, then we have to be a bit more precise so that we can correct and get to, let's say, a kilometer, hopefully 100 meters to the target that we want to achieve.
Most space agencies will send the Mars hab and supplies ahead of the crew. This splits up the weight and gives engineers a chance to rehearse the landing. The problem now is putting the second dart in the same spot.
The second you say that you're going to put stuff on Mars ahead of time, you have no choice but to land near that stuff. If you're 200 miles off course and you have no vehicle with you that can travel 200 miles over the surface of Mars, you're going to die.
James Cameron is part of a team at NASA that's developing a stereo motion camera for the Mars Science Laboratory in 2009. But Cameron is playing with ideas as well as pictures. He's come up with a unique lander that may solve the problem of that troublesome uncertainty ellipse.
It occurred to me, why not land in your rover? It's already a spacecraft, essentially.
So Cameron combined the lander with the rover, giving the crew a way to get to the Mars hab once they reach the surface. A revolutionary idea that neither the Russians nor NASA had considered.
People like Jim Cameron, who've thought about exotic, hostile environments, bring a new perspective to the idea of sending machines and people to places like Mars.
We've lost guidance! The astronauts are about to hit the final minute of those 6 minutes of terror. 60 seconds that will change forever the way we see our universe. The first manned mission to Mars is just 60 seconds from landing on the red planet.
There are huge challenges that are in front of you. Will it be a cakewalk? Will it be easy? No, but remember, they're very well trained to survive the adversity that's in front of them.
This is the moment they have trained for. Everything has to work the first time.
LiDAR, unable to find a landing location!
There will be no second chances.